Hi mathematicians, and welcome to the Unit 5 Lesson 6 review on angle, side. So today for angle, side, we are going to be reviewing this idea of having two angles, any two angles, and any side, using that information to prove congruence. So if you see here, we've got two angles and a side, and these two triangles are in fact congruent. So two pairs of congruent angles, one non-included side, right? And remember here that rigid transformations, they maintain congruence. So no matter how much we flip, slide, rotate our figures around, our figures are going to be congruent. It's just going to take a little bit of work identifying those corresponding sides and showing that they are in fact still congruent. So let's get started on some examples. So the first example here is on some figures that have in fact been translated, right? We've got a slide and then some rotation happening here. And we've got some reflection here. We're going to dive a little bit deeper into those. But if you do see in this case here, right, it's kind of a little bit easier to match up our corresponding angles here, right, with the translation. But then we need to do a little bit of work to show this reflection, right? Or it looks like this is our single arc mark here. So these are corresponding, but it might not be like quite a true reflection. There may be a little bit of rotation in there to get them, but maybe it is a true reflection, right? Because our angles are faced the opposite direction. But in this case, right, our arc mark is telling us that A prime is congruent to D, so it helps us kind of orient how our figure, our triangle, is changing. Here we have a reflection, and we are going to talk more about how we can prove or show that angles are congruent after and before the reflection. Also looking at the fact that the reflexive property of congruence shows that side B double prime C double prime is going to be congruent to EF. Going on to our next example, I want to first reteach the triangle angle sum theorem. We talked about it in the vocabulary video that is right before this one, but I want to show more on how it applies to triangles and translations in showing congruence. So we, first and foremost, I guess I should tell you again, just in case you missed that video, what the triangle angle sum theorem is. And it basically says that if we take all three angles of our triangle, it equals 180 degrees, right? When we learned about triangles in the past, we were told that all the angles add up to 180 degrees, but we maybe were never told what that theorem is, and it's the triangle angle sum theorem. But how does it apply to our triangle? So we have this figure here that I showed prior, right? And we have congruent angles and congruent sides. So we are told that angle D is congruent to angle A double prime. And we are told that's by arc marks, right? We have a single arc mark. And then we're also told that angle E is congruent to angle B double prime here by our arc marks. And then our last bit of information that we are given is that side FE is congruent to C double prime, B double prime. Okay, so this is all of our given information from our triangle. And in order to identify or show that angle F here is congruent to angle C, we can actually use the triangle angle sum theorem. And basically what that's saying is angle D plus angle, and actually, let's change this. It's specifically the measure of angle D. That's what this M stands for, the measure of angle D, plus the measure of angle E, plus the measure of angle F is going to be equal to 180 degrees. And we can write that same exact thing, A double prime, measure of A double prime, plus the measure of B double prime. I'm writing them in corresponding order here, plus the measure of C double prime is equal to 180 degrees. So how do we know that the measure of angle F and the measure of angle C double prime are congruent? Well, we're told that the measure of angle D and the measure of angle A are equal to each other. We're told that the measure of angle E and the measure of angle B double prime are equal to each other. That means that when we're subtracting, right, the measure of angle D and the measure of angle E from 180 degrees, we're given a specific number. When we take the measure of angle A double prime and the measure of angle B double prime and subtract it from 180 degrees, we can only have one angle measure, right? When we're adding, we can't have different numbers if everything else is the same. That means that the measure of angle F and the measure of angle C prime have to be the same, right? If everything else is the same, those two have to be the same by the triangle angle sum theorem. Okay, keep that in mind when we are trying to prove angle side congruence. Let's move on to our next example here. And if you watched the video for our vocabulary, you'll know I said that angle side is kind of angle side angle in disguise. And that is because by the triangle congruence theorem, if I have these two angles that are the exact same, right? L and K and I and H are congruent to their corresponding sides, there's no other value for G. There's no other value that could be G, right? These two have to be the same. So if we knew that this was 60, well, actually, we'll do the bigger one. This one was 90 and this one was 30. And we knew that because they're congruent, right? Single arc marks, this has to be 90 and this has to be 30. The only value that J and G could be is 60. That's the only value that makes it so that all three of these add up together. And that means that when we do a little bit of work, we actually have, in this case, let me change my color here, we actually have angle, side, angle, angle, side, angle, okay? But the perk is that we don't have to do any of that front-loading work of identifying what our third side is because we have the angle side angle theorem here. As long as we have two angles and one side that are congruent and corresponding, that means that our triangles are congruent. How are angle side and angle side angle different from each other? So let's look at this example here. Consider the following diagram. What additional piece of information would you need to be able to state that triangle ABC is congruent to triangle DEF by angle side angle? When you are doing your questions, answering your questions, whether it be in the quick checks or whether it be in the tests, pay attention to what congruence theorem we are asking you to use. We are asking you to use angle side angle. So that means that when we are walking around our triangle, we start at B, we've got an angle, then we go to A, we've got another angle. Our third bit of information is a side. If you guys were to say the bit of information that are needed is that side AB is congruent to side DE, right? That's showing that these two are congruent. We do not have angle side. We have angle side angle, right? This is an included side. We don't want an included side. We want a non-included side. So that means that we don't want this. We want our first angle, we want our second angle, and then that means that either one of these sides are the side that we want. So we either want the fact that AC is going to be congruent to DF, or we want that CB is congruent to ED. Or let's double check. ACB 1. Yeah. Oh no, EF. Or FE. Let's rewrite that. FE. Didn't feel right. So we want either AC is congruent to DF, AC, DF, or we want CB congruent to FE. These are the two sides that we would want the information for to prove angle side, right? We do not want our included angle. We want a non-included angle. So that is how they are different. Now let's do a little bit of an example. We're given 3 triangles. We need to use angle, side to show congruence. So in this case, we're looking at triangle number 1. We've got an angle, which is 37, an angle, which is 87, and then we've got a side. So we have angle, side. This could very much be one of our congruent triangles. Let's look at triangle number 2, right? And the other thing we want to make sure here, right, is that they are corresponding. So if you look here, if I were to rotate this triangle up, we would kind of, shift, tilt, or not tilt. If we tilt our head and then turn, right, that would be our rotation that we have. We would have that same 31, 87, and 3.16 as we're walking around our triangle like this. This also is going to be congruent. Let's see if our triangle 3, maybe they give us 3 congruent triangles. So we're starting in this case, we're starting with 31. Awesome, great start. Then we've got 87, also a great start. But for both of these ones, our 3.16 is the following side after 8.7. And this one makes you go, oh, around to the other side. And remember, when we're talking about congruence theorems, we need our triangles to be corresponding and congruent. Although they have the 3 sides, this is not the corresponding side, so it does not work as one of our congruent triangles. Okay, so next let's look at example 3. And example 3 brings up our vocabulary word perpendicular bisector. So first and foremost, we have triangle ABC. And they tell us that triangle ABC is isosceles. By definition of isosceles, we have 2 equal sides and 2 equal angles. But luckily enough for us, they describe in our question what sides and what angles are equal. Looking here, we've got angle AB is congruent to CB, and we have angle A is congruent to angle C. So these are our 2 sides and our 2 angles that are going to be congruent to each other. The next bit of information that they give us is that BD is perpendicular to AC. What that means is that we have a perfect 90-degree angle here. We want to figure out why triangle ABD has to be congruent to triangle CBD. We are in the angle side unit, our lesson, and so there is many ways that I could show that these are congruent using the other one, but let's focus on angle side. Because BD is perpendicular to AC, what that means is that, right, we've got the perfect 90 degrees. It's perfect 90 degrees on both sides, not just one side, because that wouldn't make it 90 degrees on the other. It is perfectly 90 degrees on both sides of our line segment that we have here. So with this definition, right, we have angle side, because we have angle D. Well, actually, we have to name it the full name. only because in this case here, right, we have technically two angles that are attached to angle D. So we're actually going to name our angle here on the right angle B as the first point, D as the vertex, and C as the ending point. So angle BDC is going to be congruent to angle BDA by definition of perpendicular, okay? By definition of perpendicular, or I could use the symbol there, perpendicular. Then we know that it is given, right, that angle A is congruent to angle C, and it is given that AB is congruent to CB. Therefore, by angle, side, the triangles are congruent. And I'm just going to write triangles are congruent, okay? These two triangles are congruent. We also want to explain why BD must be a perpendicular bisector of AC. Perpendicular bisector meaning not only are they perpendicular, so we have two 90-degree angles, but bisector meaning it cuts it directly in half. So we have to say why AD has to be congruent to CD. Remember that really long acronym? Corresponding parts to congruent triangles are corresponding, CPCTC. We just proved, okay, that our triangles are congruent. Well, AD and CD are corresponding. That means that because my triangle is congruent, AD has to be congruent to CD by the CPCTC theorem, okay? If these two are the exact same size and we have a perpendicular line, that means that they have to be perpendicular bisectors. By definition of a perpendicular bisector, we need 90 degrees and equal length, and we have 90 degrees and equal lengths. Let's move on to the next practice problem, which is showing why these parallelograms, right, or proving that these parallelograms are congruent by angle, side. The important thing to remember is that the line that we are dividing our parallelograms matters. We've talked about it in class about how if we were to cut a parallelogram kind of against this like opposite bias, if we were to draw a line across here, we actually wouldn't get the exact same shape on the other side. In order for this to happen, we need our figure to be more of a kite than it would be a parallelogram. So because these two figures here are cut on that wrong bias line, that means that these two cannot be congruent shapes. They can't be. So we're going to look at the correct way to cut a parallelogram to create two equal triangles, and that is these two here, right? If we were to, these 2 points here are exactly opposite of each other. If we were to reflect them across, we would have the same exact shape. So looking at these two, we need to figure out which quadrilateral is divided into two triangles that can be proven. And to do that, we want to make sure that we have, angle, side, corresponding angle, sides that are congruent. So if we're looking here at ABCD, we have two parts of the triangles that are, the angles themselves are congruent. So angle D is congruent to angle B, and angle A is congruent to angle C. Remember that reflective property, right? By these two are perfect reflections of each other. That means that by the reflexive property of congruence, line segment AC is congruent to CA. These are the exact same line. So for our parallelogram, in this case, ABCD, we have two angles that are congruent and a side. This follows the angle side congruence theorem. Looking over here, for this figure, we're told that we have one angle that is congruent and a side that's congruent, but we're not told that any other side measurements are congruent. Just by the reflexive property, we know that we have another side that is congruent, and that is why W is going to be congruent to WY. This does not follow angle side, right? In this case here, there's other congruence theorems that we could use to prove it, but specifically we want angle side. So A, B, C, D is the one that we are looking for. Practice problem number 2. According to the labeling, right, in the diagram, angle A is congruent to which one of these angles? And it's A double prime, I should say. So this one right here, angle A double prime, what angle is it congruent to? Is it congruent to D, E, F, or C double prime? Well, in this case here, we are actually given specific marks, which make this super easy and quick to find out. This is why I tell you all the time to mark up your triangle, mark up those corresponding sides, because anybody can look at this and go, hey, angle A double prime has a single arc mark, and so does D. That's showing that those two are congruent. So it's a very quick statement that angle A double prime is congruent to angle D. This is why we mark our triangles. Practice problem number 3. Based on the given information in the diagram, what additional information is needed to prove that triangle ABC is congruent to triangle RPQ by the angle side congruence theorem? Angle side, we are given two angles. So we have angle A here that corresponds with angle R. They're both 40 degrees. And I wish they did arc marks correctly here. But we have angle 91, angle C is congruent to angle Q. These are the ones we are given. We are working with angle side. So we do not want the included angle between them. We specifically want a non-included angle. That means that the angles that we want to show are congruent are either AB, option 1, which is RP here, or we want CB, which is QP on our other triangle. We want one of the other ones. So we're going to go down our options and see which one fits best. AC is the one specifically that we said we did not want because it's included. So option 1 is a no-go. We want angle side. We're already given two angles, so we don't want another angle. We want another side. So then we look here at BC. BC is our second option that we talked about, and BC is congruent to PQ. That is, in fact, the the side that we would like to know information on given our three options. The last practice problem that we have here, these triangles are congruent by angle side congruence theorem. They're telling us that they are congruent. They are showing this beautifully labeled triangle here, right? We have all three sides labeled, and we have all three angles are also labeled. And we want to figure out what is the length of A. So here, once again, this is why we mark our triangles. It is going to help us in the long run. We are looking for A. A is a single tick mark. So here, right, we're looking for our single tick mark. We have our single tick mark. The value, the length of this line segment for the single tick mark is 5. That means what is the length? It is 5 units. Whatever units we're doing, I'm not sure. Chances are the text just wants you to put in the value 5, but that is why we do our tick marks. We know automatically that these ones are congruent. We don't need to look and see, okay, we're between 50 and 70, the single mark and the double mark, right? Between the single and the double, okay, it's 7. We don't need to do that because we have labeled. All right, guys, that is it for this lesson. Please reach out if you have any questions or need any help, and until next time.